So we got Unit 3, Lesson 4. Just kind of a heads up, and Zach, he's been on Moodle a lot. Hopefully some of you guys can follow suit when you guys miss. But since we changed my units, all my units on Moodle are one behind. Yeah, one behind. So like all this stuff I did in Unit 2 last year, so I just changed it today. So now there's like a new Unit 3, so everything's been updated today. So just so you guys know, when you're on Moodle and you're looking at these videos and stuff, I updated all the titles, so now they're actually accurate to what we're doing. So now we have 7 units instead of 6, because we broke Unit 2 into 2. Make sense? Okay, so, all right, so we have equations and intercepts from the vertex and a point. So this is Unit 3, Lesson 4. In the last lesson, we analyzed how we, in standard form, what the A does, what the P does, and what the Q does. Okay, so here's kind of the steps for what we're talking about. The following procedure will enable us to write quadratic functions in standard form if we are given the coordinates of the vertex and another point on the parabola. So they give us the vertex and another point. What is the only thing we really have to solve for? Like, think about what we know about the vertex. If we have the vertex point, what is our only mystery in terms of the standard form? Looking right here. What's our only thing that we don't know? Yeah, A. Because the vertex is P and Q, right? So when you have the vertex, you have P and you have Q. The only thing that's the mystery is the A. Okay, so that's what we're doing today, is we're working on solving for the A. So that's why it says replace P and Q with the coordinates of the vertex. So we plug P and Q in. Replace an X and Y. If they give me a point, if you're looking up here, we have an X, a Y, a P, and a Q. Every variable is gone except for A. So now we have a simple algebra problem where we're just going to solve for A. Okay, so they're giving me 4 numbers, and you have 4 places to put them. Okay, solve for A, replace the values of A, and then write your answer. Fair enough? Simple enough? Always make it sound easy, then doing it might be a little different, right? Okay, all right, so let's look at example 1. All right, the graph of the quadratic function has a vertex of -2, 8, passes to the point -1, 7. Okay, it says find the equation of the function in standard form. Okay, so in standard form. So this is what we're talking about. We need to recognize when you see this, you need to be like, okay, there's my P, there's my Q. Okay, there's my X, and there's my Y. Now this is where we have to really be good at the opposite game. Okay, when you plug in, this is how it gets opposite. When you plug in a -2, what's minus a minus? The plus. So that's why when it's left 2, we're just going to put +2 every time. That's why I kind of taught you that way, so you don't have to worry about negatives. So when you see this, instantly in your head, I hope you're thinking this is an X plus 2 one. I hope that's how you approach it. Okay, and then we have, I'll just put in just P and Q first. Okay, and then my Q is 8. And we have Y equals. So I put in 2 of my information, 2 numbers for my information. Okay, let's put in the other 2. So my X and my Y. So put my Y here is going to be 7. My A is what we're trying to find. My X is -1. Okay, now you can see it's going to be kind of nice once we get that thing squared, because it's just going to be an algebra problem. -1 plus 2 is 1. 1 squared is 1. So it's just going to be 7 equals A plus 8. And all I have to do is minus the 8. So it tells me my A is -1. So our answer, in terms of writing in standard form, is like our example on the board, negative, you can put a 1 there if you have to, but you don't need to, X plus 2 squared plus 8. That's the standard form of our equation for this parabola. Okay, now the thing I told you, this is how easy standard form makes it to graph. I know where my vertex is, right? It's left 2, up 8. Right there. That's where my vertex is. Okay, and I don't have a stretch, right? So I know it's going to be, when you don't have a stretch, what's our normal x squared pattern? 1 is, what's 1 squared? 1. 2 is 4, right? So over 1, down, or over 1, down 1. Over 2, down 4. 1, 2, 3, 4. And I'll mirror that. So right here, this is what my graph's going to look like. That's a good rough sketch. Okay, I didn't do any calculator work. That's just knowing my vertex point and then my stretch factor. Okay, now it wants us for part B to rewrite the equation in general form. So who knows or who wants to give a suggestion of how we can make this general form? What could we do? No takers? You just FOIL this out. You FOIL this out and combine your like terms. So I would go, I'm going to move up here so I don't have much room down here. For part B, I'd go y equals, I just leave the negative out here. Okay, I'm going to go x plus 2 times x plus 2, and then we'll have a plus 8. X plus 2 times x plus 2, we'll just leave the negative out here still. It's going to give me x squared plus 4x plus 4. Okay, and that negative hits everything. So all three of these turn to negative. Okay, that's why I left it kind of hanging out so we get that stuff sorted out. So it's going to be negative x squared, negative 4x. What's a negative 4 plus 8? 4. That's your general form. Okay, now check this out. What does this number mean? We talked about this one lesson. What's it? The Y-intercept. So let's go over here. See this dot right here? Where's it at? It's at 4. Okay, it all comes together pretty nicely. So immediate tip-offs for standard form is if it's a flipped yes or no, the movement of the center of the graph. The only tip-off for general form is if it's flipped or the Y-intercept. Okay, so they both kind of have their own little things that can help you. I think, again, well, I know that standard form is the most descriptive of the graph. All right, and then it says, okay, so then it says it wants you really quickly on your calculator to find the Y or the X-intercept and the Y-intercept. We don't have to find the Y. We already know the Y is 4. So my Y-intercept is 4. And then we want to find the two X-intercepts. We have 2 of them. We have that one and that one. So we need to figure out what those are using your calculator. Okay, remember that's a 0 function. You hit the 0 function. You go left of it, right of it, and then guess around it. Give you about 60 seconds here to kind of punch that in, and I'll share with you the answers. We'll see if you're close. No, you don't need to intersect. It's going to be second trace. Number 2. Left bound, so hit left. That's left bound, enter. Hit right, enter. No, stop, no, we don't be on the other side. You want to be, because we're trying to get this guy. We're surrounding this one. You have to do this thing twice. So enter, and then go close, enter. That's your first filter. You do the same thing I just did on the other side. Okay, so remember, one more time, the process. You're going to hit second trace, number 2, which is 0. It's going to say left bound. With your cursor, your left bound should be somewhere down here. You're going to hit enter. Then you're going to pass it to the right, which is up here. Hit enter, and then it's somewhere close. And this right here, the first answer is negative 4.8. Right? Yeah, 4.83. Okay, and you do the same process over here. This side's left bound, right bound, guess, and you'll get 0.043, 0.83, excuse me, 0.83 for your answer on this one. Okay. All right, so let's go and use this. So we got one more page. If you need help with the calculator, I can help you after this is done. So last little stuff here. All right, determine the exact values of the x and y-intercepts of the graph of the function f of x. Okay, so it wants us to do this in terms of algebraically, so not using our calculator now. So when you're finding an x-intercept, what do we like to do? What's that? Y equals 0. Good. So if we're finding x-intercepts, you want y to equal 0. So we're going to put 0 in here. And we're going to solve for x. So we're going to do it piece by piece, just like algebra. I'm going to add 9. Okay. I'm going to divide 3. Okay, so that's where I'm at so far. I'm going to square root. Square root 3 equals x minus 1. And lastly, I'm going to add 1. Okay, and when you're solving with a radical, this is always going to have a plus or minus in front of it. It can be plus or minus that. Oh, excuse me. Okay, and so we'll have 1 plus or minus root 3 is what x is for your intercepts. Why is it plus or minus? Well, because how many zeros do we usually expect? 2. Okay, so that's how we have two answers. Your first answer is 1 plus root 3. Your second answer is 1 minus root 3. Does anyone want to take a guess to why that makes sense? What do we know about parabolas? Are they oblong? Are they symmetric? Like, they're all symmetric, right? So whatever I add to 1, I have to subtract from 1 to make it symmetric, so they have the same property. Okay, so they are symmetric, so you're going to have that kind of relationship a lot when you're getting two zeros. All right, so that's your x-intercept. So then we're going to find our y-intercept. So for our y-intercept, it's just the opposite. Make x equals 0. Y equals 3 times 0 minus 1 squared minus 9. And you just evaluate. Okay, 0 minus 1 is negative 1. That squared is just 1. So we have y equals 3 minus 9. So my y-intercept is negative 6. Okay. The y-intercept is generally easier. That's why I went a little bit faster. We got one more example. We good? Okay. All right, so the graph of the quadratic function is shown. The maximum point is shown. Find the equation of the function in standard form. So it's telling you the maximum point is shown. So this right here has to be the maximum point. Maximum point is also the what? Vertex. Okay? The vertex helps us to figure out what standard form is. So this is what we're going to do. We're building this equation from this picture without having any information on it. We know, let's just one more time, we know we're looking for this. Okay, my P and my Q, my P is negative 1. Okay, and my Q is 2. So since it was negative 1, I know I'm going to go A times X plus 1 squared, the opposite. And my Q is 2, so I'm going to have a plus 2 on the end. Now, that's where this random point they put on there helps us, or is here for us. We're going to plug this in for X and not in for Y. So we have 1 equals A times negative 3 plus 1 squared plus 2. Okay, so that gives me negative 3 plus 1 is a negative 2. Negative 2 squared is 4. All right, and we're just going to solve. Minus 2, and divide the 4. So A is a negative 1/4. So it is a compression, and it reflects. It's a compression, and it reflects. So my final answer for standard form would be this. That's your final standard form 1. move it up here. We're going to find the X-intercepts and the Y-intercepts now. All right. All right, so let's go for the X-intercept first. That's the harder one. So X-intercept, make y equals 0. So we're going to have 0 equals negative 1/4.
Junior class change.
That's what we're going to have, and we're solving for x. I will tell you this. When you're doing these type of problems, if you ever get to a point where you have two variables, then you've done something wrong or you haven't plugged something in. Okay? We're not doing anything where you have to solve for two variables. Okay? So that's just kind of a tip-off of when you know you're doing the right thing or not. Okay, so first thing, we're minus the 2. Okay, how do you get rid of 1/4? What's that? Multiply by? Yeah, negative 4. Right, yeah, is that what you said? Sorry. Multiply by negative 4. So I get 8 equals x plus 1 squared. We're going to square root. We get root 8 equals x plus 1 minus the 1. We get negative 1 plus or minus root 8 equals x. You can leave it like that, or you can break the root 8 down, which we've learned how to do in our radicals. Root 8 breaks down to 4 times 2, so that would give me negative 1 plus or minus 2 root 2. That's your x-intercepts. Again, it's plus or minus because there's 2. There's 2 intercepts. Yes, Sam? I would say, I'll tell you this, on your multiple choice, that's the answer that's going to be there. So if you put that on a short answer, I probably wouldn't mark it wrong. Okay. All right. So that's my x-intercepts. And my y-intercept, the easier one, we're going to make x equals 0. So I'm going to go y equals negative 1/4, 0 plus 1 squared plus 2. Okay, so we have a little fraction work here to do. 0 plus 1 is 1. 1 times negative 1/4 is just negative 1/4. So that's negative 1/4 plus 2. Well, the way I like to do all these things is I know that 2 has 8/4, because these are equal, right? 8/4 is 2. And so our answer is 7/4 for the y-intercept. All right. That's basically it. We're going to talk about the domain and range here, but that's basically it. Any questions on that? Okay, it's got a lot of just using your algebra. Yes? You just FOIL out the I don't know what you want to call this, the perfect square. You're just going to write that side by side, FOIL it out, and then combine your like terms. Yep. Anything else? Good question. Okay, so then state the domain and range of the equation and the axis of symmetry. Okay, so our equation is, where is it at here? I'll write it again right here. So y equals negative 1/4 x plus 1 squared plus 2. Right, here's our equation. What is the domain? Is there any limitations on my x? Is there anything my x can't be? No, so my domain is all real numbers. Okay, now for my range, is there any limitation on my y can be? There is. Now look at the picture. Do we have a max or a min? We had a max. So that means that I have to be that number or what? Lower. So it's less than or equal to, what was our max y value? 2. It was the 2 because it was the 2 of the vertex. Right? That's our highest point. Okay? And what's my axis of symmetry? It's always the what? So if your vertex, our vertex is negative 1 and 2. This is our max or min. And then this is our what? Your axis of symmetry. So your axis of symmetry is x equals negative 1. If you had a negative 1 vertical line, it'd go right through a parabola, cut it in half. Okay? All right, that's it. So